Okay, Chapter 2, Lessons 5 and 6, and this is a big one, solving one-step equations. All right, when solving an equation, yesterday we talked a lot about equations. When solving an equation, your goal is to find the solution to the equation. So remember what that is. That is the value for the variable that can make that equation a true statement. Basically, when we end up with our answer here, we want one variable equal to some number. In order to do this, we are isolating the variable because the problems that you'll be given have a variable. Something is being done to it, some kind of operation, and it equals some kind of numerical expression or variable expression later on. So we want to get the variable by itself because our goal is we want to know the one variable equal to some number. And in order to do this, we use our inverse operations that undo each other. We have pairs of inverse operations. We have addition undoing subtraction, and subtraction actually undoes addition. They undo each other. For example, if I have 5 plus 2, it equals 7. Now if I'm starting with 7 and I want to go back to 5, I subtract 2. It's kind of similar to like being in the store. Say you want to go out and buy the newest Call of Duty video game. You would go to the store and you basically subtract $60 from your bank account. Say you get home and the game is broken. Well then, when you go back to the store, they're adding the $60 back to your bank account and you're back where you're starting. Another pair of inverse operations would be like multiplication and division. Multiplying undoes division and division undoes multiplying. For example, if I have 3 times 4, it equals 12. And if I want to go back to 3, well, I would divide by 4. Let's get back to 3. We're always going to be using inverse operations on both sides of the equal sign. You must maintain balance. Okay? You must maintain balance. So I'll show you what I mean with a lot of examples. Starting with example 1, we have y plus 8 equals 12. Now, I need the variable by itself. Y must be by itself. So what do I have? I have a plus 8 here, and I need to get rid of that. In order to do so, since it's plus 8, to undo that, I use my inverse operation of subtraction. So I'm going to subtract 8 from both sides. I have to use both sides because I have to maintain balance. It's like being a weightlifter at the gym. If you're lifting a bar of weights, you don't just take 10 pounds off one side and say, all right, I'm good. You have to do it off the other side as well. Otherwise, it's really awkward. So when I subtract 8 from both sides, I have 12 minus 8, which is 4. And these, since they're inverse operations, undo each other and they kind of cancel out. So we end up with 1y equals 4. So y equals 4. Checking our answer, 4 plus 8, that is 12. So we are correct. Moving on to something a little bit more complex, notice here I have 7 plus f minus 21 equals negative 20. Now the first thing I need to do before I start doing stuff to both sides or anything like that is I want to combine any like terms before I go move ahead. So I have a 7 and a minus 21, which is negative 14. Remember, I can be doing adding the opposite, so 7 plus negative 21 is negative 14. When I combine those terms, I got f minus 14 equals negative 20. So what am I going to do now? I'm going to use my inverse operations. I'm going to add 14 to both sides. These will cancel out, and negative 20 plus 14 is negative 6. So we're going to see if negative 6 is our answer. 7 plus negative 6 is 1. And 1 minus 21 is negative 20. So we got that one right. Let's look at example 3. 67 is equal to g minus negative 36. First things first, whenever you see a minus negative, you should immediately going, oh, that's the same as adding. So now that we know that, since we're adding 36, we want to subtract 36 on both sides of the equal sign. When we do that, 67 minus 36 is 31. So let's check and see if we got that one right. It's 31 minus negative 36, 67. Or is 31 plus 36, 67? It sure is, so we got that right. Now let's use a little multiplication division. We have 8 times x equals negative 48. To undo multiplication, we divide. So we're going to be dividing both sides by 8. When we do so, negative 48 divided by 8 is negative 6. The 8 over 8 doesn't cancel out completely. It actually simplifies to a 1. So it's 1x, or we could write that as just x. So x is equal to negative 6. Let's check our answers, see if we're right. 8 times negative 6, that is negative 48, so we're good. Now example 5. We have negative 2x equals 18. Once again, this is multiplication, so we're going to divide on both sides. We're going to divide both sides by that negative 2. 18 divided by negative 2 is negative 9. And these cancel out or simplify to a 1, so 1x equals negative 9. Negative 2 times negative 9 is positive 18, so we are right. Finally, let's look at example 6. We have y divided by negative 3 equals 14. Now, I'm going to go ahead and multiply both sides by negative 3. I'm multiplying both sides by negative 3 here because the operation is division. I do the inverse. These negative 3's simplify to a 1 because this is like saying negative 3 over 1 times y over negative 3. And if you remember your fraction multiplication, this basically will cancel out to a positive 1. 14 times negative 3 is negative 42. So my final answer is y equals negative 42. Pause, let's check that. Negative 42 divided by negative 3 should be positive, negative divided by negative, and that's a 14, positive 14. Notice how I write these equations. Notice how I write all my work and how ordered and neat it is. I expect you to write it this way as well. This may be easy for now, and you may be thinking, oh, I can do most of these in my head. But soon we will have equations with variables on both sides, equations with fractions all over the place, and it's not as easy as it looks. Get in the habit of writing it down methodically, and it'll be much easier later on. All right, I'm Mr. Bajork, and this was Solving One-Step Equations.